Welcome to chemistry class. Today's topic is Joul-thomson effect. Okay. So first let us see the pictorial representation, the schematic representation of Joul-thomson effect. After that we will go through the theory. So see here, this is schematic representation. According to Joul-thomson effect, when gas expands from high pressure region to low pressure region, then it gets cooled. Okay. Here in this picture, the P1 is high pressure region, like this area is high pressure region, this area is low pressure region, this is porous plug. Okay. So if you allow to the gas to expand through the porous plug, then the pressure acquired is P2 and the temperature is T2. Okay. Initial temperature is T1, initial pressure is P1. When you allow to expand the real gas through the porous plug, then the temperature changes from T1 to T2 and pressure changes from P1 to P2. Okay, this is low pressure region. Okay, during this gas gets cooled. Okay, so here the conditions are during Joule-thomson effect, P1 is greater than P2, T1 is greater than T2. Okay, let us go through the theory. Joule-thomson effect. So Joule-thomson effect is simply speaking, it is a cooling effect. When a gas expands from high pressure to low pressure through a porous plug, then it gets cooled. Okay. So the temperature of real gas decreases during expansion from high pressure region to low pressure region is said to be Joule-thomson effect. Okay. So here simply we can define this like this: cooling of a gas during expansion from high pressure region to low pressure region. Through a porous plug. Through a porous plug. Okay. So this is said to be Joule-thomson effect. అంటే ఒక గ్యాస్, ఒక రియల్ గ్యాస్ హై ప్రెషర్ నుంచి లో ప్రెషర్కి ఎక్స్పాండ్ అయ్యేటప్పుడు ఇట్ గెట్ కూల్డ్. The temperature of that gas will be decreased. This is said to be Joule-thomson effect. Okay, so we can experience like this also. If you blow the gas from your mouth like this, okay, then you experience some extent of cool. Okay, so that is about Joule-thomson effect. Let us see what is inversion temperature. Inversion temperature. Okay. So what is meant by inversion temperature? Inversion temperature means the temperature below at which gas gets cooled during expansion from high pressure region to low pressure region. Okay, the temperature below at which gas gets cooled during expansion from high pressure region to low pressure region is said to be inversion temperature. So see here, the temperature below at which real gas gets cooled during expansion from high pressure region to low pressure region. This is said to be inversion temperature. Joule-thomson effect and inversion temperature are interrelated. Okay. So now, for example, if you want to cool helium during expansion from high pressure region to low pressure region, the inversion temperature for helium is minus 242 degrees centigrade. This is inversion temperature of helium. Is it clear? Joule-Thomson effect is an adiabatic process. Joule-Thomson effect is an adiabatic process. So adiabatic process means you know very well. The process takes place in insulated system. Okay. So insulated system lo jarige process ni adiabatic process antaru. Okay. Enthalpy remains constant during Joule-Thomson effect. Enthalpy remains constant during Joule-Thomson effect. Okay. Let us see the applications of Joule-Thomson effect. Okay. So now it is the basic principle involved in air conditioners. ఎయిర్ కండిషనర్స్ లో ఉండే బేసిక్ ప్రిన్సిపల్ ఇదన్నమాట. అంటే ఇక్కడ చూడండి, మనకు ఆ ఏసీలో కాపర్ పైపులు ఇస్తాడు. ఏసీ ఇచ్చేటప్పుడు, ఎయిర్ కండిషనర్ ఇచ్చేటప్పుడు ఆ కాపర్ పైపులో ఒక చిన్న కాపర్ పైప్ ఉంటుంది. దట్ విల్ ప్రొవైడ్ ద పోరస్ పాత్ టు ద రియల్ గ్యాస్. ఓకే. సో ఎయిర్ కండిషనర్స్, ద ప్రిన్సిపల్ ఇన్వాల్వ్డ్ ఇన్ ఎయిర్ కండిషనర్స్ is based on Joule-Thomson effect. Number 2, liquefaction of gases. Liquefaction of gases. Gases ni liquefy cheyalante mundu temperature ni తగ్గించాలి. టెంపరేచర్ ని తగ్గించిన తర్వాత liquefy అవుతాయి. సో ఈ Joule-Thomson effect లో టెంపరేచర్ తగ్గడం అనేది జరుగుతుంది కాబట్టి this is basic principle in liquefaction of gases. Okay. Oil industry. These are fundamental applications of Joule-Thomson effect. Okay, thank you.